Hey everybody, it's Felix. Welcome back to InventBox, where the solution is right around the corner. In today's tutorial, we're going to hook up an LED and a button as external inputs and outputs onto the Arduino, and to do that, we're first going to have to set up some circuitry. Let's build something real quick that has just a simple input and a thing we can use to indicate output. I have a little push button here that when you press down, it connects the wires, and I have an LED here. Usually the longer side is positive, and if you look in here, it's the smaller side with a point on it that's positive. And then I have a 220 ohm resistor just to pull the voltage down so that 5 volts doesn't burn out the LED. This side is minus, so I'll put black on it. White on the other side. And then what we'll do is hook up the black to ground, and then white to pin 13, because that's already our LED pin. So we're just hooking up an external LED to the same pin. And then for the switch, connect one wire to each side of the switch and put one side of the switch on ground and the other one on pin 8. It doesn't really matter which pins you pick as long as they're digital pins. Now that we have the circuit built, let's go ahead and create a new project. We'll close the old one and I'll save it as external IO, because why not? So the first things we need to do are define what pins we're using. We need to make variables for that, so we'll have an int LED, and that's going to be pin 13, and then we'll also have a button, and that we plugged into pin 8. And because these are never going to change in the program, we can make them const variables. That'll keep them out of our SRAM, so we can save some space. And then, like we did in the first video with the LED, we need to tell Arduino whether these are inputs or outputs. We use pin mode for that. LED is an output because we're going to be putting voltage on it, and then the button is an input because we want the Arduino to be listening for what's happening with the button. And now that those are set up, we come down here, and in order to know what is happening with our button, there's a command called digital read that you can use on something that has been configured as a digital input. So since button is a digital input, we can digital read it, and then this is going to give us either high or low. 0 or 1, depending on what button is. Now what we can do is save digital read, which is either high or low, 1 or 0, 5 volts or 0 volts, into a variable. And since it's a 0 or a 1, we can use integer and maybe just name it pressed. So now we have the state of button saved in a variable that we can access later. Now what we want to do is turn on the LED, or make the LED pin high if the button is pressed. Well, we tell the LED pin what to do with digital write because we configured it as an output. So we give it the LED pin, and normally we would say high or low. But because high or low is stored in this pressed variable, we can just put pressed in here. Now theoretically speaking, this is all we need for this program to work. It won't quite work, but I do want to show you why. So let's go ahead and upload it and try pressing the button. Nothing. So what is happening? Well, as it turns out, when the button is not being pressed, these wires aren't connected, and therefore the ground is actually not hooked up to pin 8. So what is pin 8 when the button's not being pressed? If it's being pressed, we know it's 0 volts because it's hooked up to ground. But if the button's not pressed, it ain't hooked up to anything. So what that means is it could be literally anything. 0 volts, 5 volts, 3.3 volts, 2.7896 volts. And as a result, what we need to do is come over here, and when we define the button as an input, we need to make it an input pull up. What that does is inside the Arduino, it ties the button to 5 volts. It pulls it up to 5 volts through a high resistance resistor, so that whenever nothing is happening to it, we know it's at 5 volts. But if we push our button, which is connected to ground, then it overrides that and it forces the button to 0 volts. So now when we don't press the button, it's 5 volts or 1, and when we do press the button, it's 0 volts or low. And that means that pressed is actually the opposite of what we think it is. If we're pushing down the button, it's a 0. So when we write our state of the button to the LED pin, we can put an exclamation mark. We call this a bang, and that means make it the opposite. If you're confused about that, all you have to do is try building and compiling this program with and without the bang, and you'll see that it makes it behave the opposite. Now that all this stuff is fixed with the pull-up resistor, let's try compiling this again. There we go. Pushing the button turns the LED on, just like we wanted. So in general summary, we hooked up a button to ground and pin 8. We hooked up an LED to ground and pin 13, so that if we want the LED on, we make pin 13 high, and when we push the button, it makes pin 8 low or ground. Then we told the Arduino to make the LEDs, to make our pins inputs or outputs, depending on what we needed. The input had to be an input pull-up so that we knew exactly what state it was in when nothing was happening. And then we saved every loop cycle we save what is currently happening with the button with digital read, and then we use that information to tell the LED pin what to do. Well, congratulations on hooking up your first external stuff to an Arduino, and if you have any further questions, please feel free to leave a comment.